The Greenland ice sheet, which covers approximately 80% of Greenland, is the largest glacier of its kind in the Northern Hemisphere. Researchers discovered well-preserved fossil plants and biomolecules at the bottom of a 1.4-kilometer core sample that was taken way back in 1966 at Camp Century during the Cold War. It indicated the massive sheet melted and reformed at least once in the last 1 million years. The sample had been separated from the rest of the core and had crisscrossed the Atlantic since being pulled from underneath the ice sheet. The samples were shoved in the back of an Army freezer at the University of Buffalo, and then they were moved incognito with a bunch of other material to another freezer at a research facility in Denmark in the 1990s. They were misplaced, forgotten, and then finally rediscovered in 2017. Surprisingly, the samples had never been examined, nor had they melted. Geology analysts were beginning the laborious process of sorting through the sediment from the core samples, washing it off before the next stage of analysis. In 2019, when they noticed strange black specks floating in the water, a few of them got collected up and examined under a microscope. That's where they discovered these specks were actually plants. As they continued to go through the core sample, scientists began to pull out 2-inch-long twigs. The discovery of these fossils proves that Greenland was once ice-free enough to support a wide range of plants. Subglacial material, which was collected from where the drills struck sediment and bedrock beneath the ice sheet, contains information that ice doesn't. Exposed rock, like anything else on Earth's surface, is bombarded with cosmic rays, producing chemical signatures. These are known as cosmogenic nuclides, and they can be used to determine whether or not an area was ever ice-free. Through the next phase of research, which is already underway, what they're looking for are DNA traces that could be used to determine the species present and even reconstruct the entire ecosystem. So far, it appears to be comparable to modern Arctic tundra land. The discovery is credited to Drew Christ, the study's lead author and postdoctoral fellow at the University of Vermont, and his team. These are Interesting Things with JC.